sklearn preprocessing function transformer. Description: the function transformer class in scikit-learn is a versatile preprocessing tool that allows you to apply arbitrary functions to your data before feeding it into machine learning models. It essentially acts as a wrapper for your custom function, making it compatible with scikit-learn's pipeline and other features. Inputs: X, a NumPy array or pandas data frame representing your input data. This is the data that you want to transform using the function you define. Function: a callable function, lambda expression, or any other object that can be called that takes a single argument, the input data X, and returns the transformed data. Outputs: transformed data. The output of the function transformer is the result of applying your custom function to the input data. The format of the output will depend on the function you define. It can be a NumPy array, pandas data frame, or any other object returned by your function. Steps: function application. When you apply function transformer to your data, it internally calls your custom function with the input data X. Output: handling. The function transformer then handles the output of your function, ensuring that the resulting data is in a format that is compatible with scikit-learn. Metrics: none. Function transformer doesn't directly provide metrics for assessing the transformation. The metrics would depend on the specific function you use. Visualization plots: none. Function transformer does not directly offer visualization plots. However, you can use visualization techniques for the output data after transformation. Fine-tune parameters: func. This parameter defines the function that you want to apply to your data. It can be any callable object that takes the input data as an argument and returns the transformed data. Validate. This parameter controls how function transformer handles the input data. If set to true default, it will check if the input data has the correct format and raise an error if it doesn't. You can set it to false if you want to bypass this check. Inverse func. This parameter allows you to define an inverse function for your transformation. The inverse function is used to reverse the transformation applied by the function transformer. You can set it to none if you don't want to define an inverse function. Accept sparse. This parameter determines whether function transformer can accept sparse matrices as input. If set to true, it can handle sparse matrices. Otherwise, it requires dense data. Check inverse. This parameter checks if the inverse function, if defined, is valid. If set to true default, it will verify that the inverse transformation correctly restores the original data. Quarks. This parameter allows you to pass additional keyword arguments to your custom function. Uncertainty methods: none. Function transformer doesn't offer uncertainty quantification methods. Uncertainty would be tied to the function you are using and any related methods it might have. Challenges and fixes. Challenge 1: function output format is not compatible with downstream models. Sample use case that resulted in challenge 1: you might apply a function that returns a list of lists instead of a NumPy array, which is not directly compatible with many scikit-learn models. Fixes to challenge 1: you can either modify your function to return a NumPy array or use an additional transformer after function transformer to convert the output to the desired format. Challenge 2: function throws errors or unexpected behavior for specific input data. Sample use case that resulted in challenge 2: the function you are using might encounter edge cases or errors when processing certain types of input data, leading to unexpected results. Fixes to challenge 2: carefully test your function with different types of data, including edge cases, to ensure it behaves as expected. You might need to modify your function to handle these cases explicitly. Challenge 3 inverse function doesn't properly reverse the transformation. Sample use case that resulted in challenge 3. You might define an inverse function, but it doesn't correctly restore the original data after applying the transformation. Fixes to challenge 3. Double-check your inverse function logic to ensure it accurately undoes the transformation performed by your original function. You can also use the checkInverse parameter to automatically check for valid inverse functions.